Hello. In this video, I'll be walking you through the assembly process of the RB-Rover and explaining its design details along the way. Many of the RB-Rover's parts are assembled onto the base frame, which was created using a 3D printer. The base frame features 10 tab holes for securing parts, and after 3D printing, the tabs are created using an M3x0.5 tab tool. Next, I will assemble for gear DC motors to rotate the wheels on the base frame. Since I want the motors to be securely attached to the base frame, I designed the frame so that the motors can be fastened using bolts through the 2 holes on the motor body. Additionally, I made grooves in the base frame to fit the protrusions at the end of the motor body for extra stability. This design might seem a bit excessive, but it allowed me to perfectly secure the motors to the base frame. Next, I will assemble the power switch for the RB-Rover. The switch is a push-lock type with a built-in LED indicator, designed for 5 volts voltage and has a 19mm size specification. To make disassembly and reassembly easier, I am also using a switch socket. Next, I use 25mm flathead M3 bolts and nylon nuts to secure the motor, preventing loosening. 2 bolts are used to fasten each motor. I have created a subassembly consisting of a socket that connects the voltage output terminals of the IP5306 module to a 19mm metal push switch. The IP5306 module, which manages the charging and discharging of the 18650 batteries, and A2's battery holder for 2 18650 batteries. Next, I will assemble the power subassembly for the RB-Rover. After assembling the power subassembly, I will insert 2 18650 batteries. The batteries should be connected in parallel, and it's important to check the polarity, as reversing it can be dangerous. As shown on the screen, the positive terminal is on the left and the negative terminal is on the right. This orientation is determined by the person designing the power subassembly, so it may vary depending on the design. Next, I will assemble the PCB that communicates with the ESP3 to CAM module and controls the DC motor and cob belly disc. This PCB is designed with dimensions of 70mm by 90mm and includes 1 Arduino Nano and DRV8833 modules. It also features terminal blocks and connectors, which are used for communication with the ESP3 to CAM module and for controlling the gear DC motors and cob belly disc. Since this was made using a standard-sized universal PCB, please consider this when designing your own. Next, I will connect the 4-gear DC motors and the power wires. In the video, the connection sequence is gear DC motor 1, 2, 3, 4, followed by the power. Next, I will assemble the cob LED. The cob LED used in the Rover operates at 5 volts and features a 20mm PCB to protect the cob LEDs from foreign objects during outdoor operation of the RB-Rover. I will assemble and use an LED holder. Before assembling the cob LEDs, I would like to ensure that the holes in the base frame printed with a 3D printer are smoothed out for the LED holder to fit properly. Connect the wires of the cob LEDs. Next, I will assemble the mid-frame. The mid-frame holds the PCB in place and has 4 magnets embedded in the corners to easily secure the top cover. The assembly of the mid-frame uses 8 flathead bolts, M3 by 0.5 10 mm. The mid-frame has 4 embedded magnets in corner. With a diameter of 15 mm and a thickness of 3 mm, the magnets were inserted and sealed during the 3D printing process. If you're using the Cura slicer, the pause at height option is recommended. The ESP32 cam is assembled on a PCB with 2 connectors, which is mounted in the enclosure and fully fixed when attached to the RB-Rover. The PCB for assembling the ESP32 cam features 14 holes in the horizontal direction and 9 holes in the vertical direction. The enclosures of E26 for O camera hole is designed to accommodate a lens protector cover from Apple's iPhone 14 Pro model, ensuring protection for the ESP32 cam's camera lens. The diameter of the lens protector cover is approximately 17.2 mm and its thickness is 1.9 mm. The enclosure is assembled using a sliding mechanism onto the U-shaped protrusion of the base frame, and it is designed to be easily disassembled without bolts for maintenance purposes. This design allows for the ESP32 cam to be easily swapped when necessary. The PCB has 2 connectors installed, one for power connection and the other for TX and RX connections for UART communication with the Arduino Nano. The top cover, which is assembled on the mid-frame, also has 4 magnets embedded in each corner. These magnets are 15 mm in diameter and 3 mm thick. They were inserted and sealed during the 3D printing process. If you're using Cura slicer, the pause at height option can be handy for this step. The embedded magnets in both the mid-frame and top cover make it easy to secure the top cover in place. To charge the 18,650 batteries assembled inside the RB-Rover, a USB-C charging port is installed on the top cover. When assembling the top cover onto the RB-Rover, one side of the charging port is connected to the charging terminal of the IP5306 module. RB-Rover can be equipped with both mechanism wheels and monster wheels. While the mechanism wheels offer impressive movement patterns, they aren't ideal for off-road conditions, so they're mainly used indoors. On the other hand, monster wheels perform exceptionally well in off-road environments. Since I've been using RB-Rover more frequently in off-road settings, this video will focus on assembling it with the monster wheels. You can easily swap between mechanism and monster wheels depending on your driving environment. Now, we will assemble the monster wheels onto the RB-Rover. The monster wheels used are designed for 1/16 RC cars with a diameter of 85 mm, a width of 46 mm, and a wheel hub hex specification of 12 mm. Based on the shape of the 12 mm wheel hub hex and the shaft of the gear DC motor, a wheel hub spacer was created using a 3D printer and secured to the monster wheel with super glue. The monster wheel, now equipped with the wheel hub spacer, is assembled with the gear DC motor using N2.5 by 0.45 round head bolts, each 20 mm in length. With this, the assembly of the RB-Rover is complete. I'll be providing detailed information about the parts and source code used in a separate video, so stay tuned. If you found this video helpful, please consider subscribing, liking, and turning on notifications. Thank you for watching.